Hello students, now we shall look at steam tables. So the steam tables uh, are very much useful in calculating uh, the various properties because these values are given in the table, be it specific volume, enthalpy, entropy for both uh, fluid as well as dry saturated vapor. So It has been it is being once again repeated here that during the change of phase from liquid water to vapor at a constant pressure, the temperature remains constant. So, like you take the case of water at uh, normal or atmospheric pressure, the boiling point is 100 degrees centigrade. Fine. So, at this atmospheric pressure, there is now fixed constant pressure, the atmospheric pressure, and the boiling point is fixed, that is around 100 degrees centigrade. So, here when the water is boiling or changing phase from water to steam, the temperature will not change. That is why it is called as latent heat, because here the temperature does not change. Each pressure has a fixed temperature of change of phase. So for different pressures, like we saw 1 bar, it is 100 degrees centigrade at which water evaporates. Whereas if you lower the pressure, as in the case of we have seen in the calorimeters, we are reducing the pressure. So when we reduce, like for example, if you reduce the pressure to 0.1 bar, then the water will evaporate at 45 degrees centigrade. Otherwise, in a, like let us take the case of pressure cooker, we increase the pressure. So if we increase the pressure to 10 bar, then the water will boil at 180 degrees centigrade. That is the saturation temperature. So just you can see the water which normally we think that boils at 100 degrees centigrade, it is at 1 bar pressure. But if we reduce the pressure to 0.1 bar, water will boil at 45 degrees centigrade, and if we increase the pressure to 10 bars, then the same water will boil at 180 degrees centigrade. So this is a very important phenomena and we should understand this. We will see this in the steam table again. This temperature is called as a saturation temperature. Okay, again saturation temperature means any addition or subtraction of heat will lead to the phase change, either from solid to liquid or liquid to gas or gas to liquid or liquid to solid. During the change of phase, the liquid water and steam are in equilibrium. So in the evaporation process, both steam and water are in equilibrium. Thus in the mixture region, pressure and temperature are not independent properties. So in the mixture region, wet region, the temperature and pressure are not independent properties. They are dependent on each other, because as we have seen, at 1 bar pressure, the boiling point is 100 degrees centigrade. So the water temperature will remain at 100 degrees centigrade. So here they in the mixed region, the pressure and temperature are not independent properties, and this because of this only, to find out the dryness fraction of steam, what we have seen in the throttling calorimeter or throttling separating and throttling calorimeter, because we are not able to locate the point in the mixed region, we are through a Euler diagram, we are throttling the steam, wet steam, so that we convert it into superheated steam and then plot the properties of pressure and temperature on the superheated steam on the Euler diagram, and then at a constant enthalpy we are drawing the horizontal line to the y-axis and finding out the enthalpy. It is only because the pressure and temperature in the mixed region are not independent properties. If the pressure is given, the temperature is fixed, and vice versa. The saturated property table lists the properties of two distinct states in the mixture region, namely the saturated liquid and the saturated vapor state for various pressures as in the pressure based table. See, the steam table are two types of table. One is pressure based table or the other is the temperature based table. The values are same. If you write the pressure in the first column, we call it pressure based table. If you write the temperature in the first column, we call it as a temperature based table. Okay. And here the steam table, especially for the saturated water steam or water tables, here it will give the properties for two things. One is in the saturated liquid state and second is the saturated vapor state, that is dry saturated vapor state. Okay. The saturated property table lists the properties at two distinct states in the mixture region, namely the saturated liquid state and the saturated vapor state for various pressures as in the pressure based table, or for various saturation temperatures as in the temperature based table. The properties provided in these tables are normally the specific volume Vf and Vg, the specific internal energies UF and UG, specific enthalpies HF and HG, and specific entropies SF and HG. See, please understand this all specific means per kg. Specific volume is per volume per kg. Okay, specific enthalpy means enthalpy per kg. Specific here means refers to per kg, one thing. And please understand all these notations when they are specific volume, specific internal energy, specific enthalpy, specific entropies, they are given small alphabets. Okay. Now let us look at this. One I had just taken one sheet here, one paper. See, now you may first thing you will have a doubt such in this saturated water and steam property tables based on pressure. See, now it is based on pressure because the first column is the extreme left. The first column is the pressure. Okay, that is why it is called pressure based table. And the second column is temperature here. It can be other way around. I can bring the temperature in the first column and put the pressure. Then it become temperature based table. Okay. Now this you please see here there are two small alphabets. One is F and small is another is a these are suffix VF and VG. This F stands for liquid, that is saturated liquid, and G stands for saturated vapor, or you can call it dry saturated vapor. Similarly, you can see specific volume like specific enthalpy HF, that is HF is for enthalpy of the liquid, saturated liquid. Hg is the enthalpy of the dry saturated vapor. Similarly, entropy SF, small sf, that uh, is for fluid, that is saturated liquid, and Sg is for dry saturated vapor or just saturated vapor. Now you take the second row, pressure is 1 kilopascal. If you take 1 kilopascal, and you can see the saturation temperature is only 6.98 or 7 degrees centigrade. Okay, whereas last row you take 100 kilopascal, the saturation temperature is 99.6, that is 100 degrees centigrade. Okay. Now you can see the saturation temperature is a function of pressure. Please understand here. If you see pressure and temperature means at 1 kilopascal pressure, water will boil at 7 degrees centigrade, and for 100 kilopascal, water will boil at 100 degrees centigrade. Okay, if you take one more value, I was telling about 10 kilopascal. 10 kilopascal means zero point 0.1 bar. I just gave example at zero point 0.1 bar, water will evaporate at 45 degrees centigrade. That is called the saturation temperature. You can see here at 10 kilopascal pressure, the corresponding saturation temperature is 45 degrees centigrade, 45.81. Okay. So you understood that temperature and pressure in the mixed region, they are not independent and they are dependent on each other. So depending on the pressure, the saturation temperature varies. Okay, and these properties we are using, like in pressure cooker, we are increasing the pressure of the vapor so that the saturation temperature increases. Okay. Now, and even in the calorimeter, throttling calorimeter or separating and throttling calorimetry, also we are using the same property. We are reducing the pressure. So when we reduce the pressure, then the temperature at which water evaporates, that also reduces. And then we are converting the wet steam into superheated steam. This you can understand by seeing these first two columns, pressure and temperature. Now coming to the specific volume, meter cube per kg. Now you just see here, first is VF. VF means it is liquid, saturated water it is, okay. So this is 0.001 means if you multiply it, this is meter cube per kg. This is meter cube per kg. So if you multiply by 1000, you will get as 1. Okay, 1 liter. Okay. That is why you see water, na, 1 liter of water will weigh 1 kg only. So you can see here there is little variation of the specific volume VF. Okay, right from 0.6 kilopascal pressure to 100 kilopascal. 100 kilopascal is almost 1 bar pressure. Next Vg. Now Vg is the specific volume of the saturated vapor. Now you see here saturated vapor here, it is 206 meter cubes per kg. Okay. So 1 kg of steam at 0.6 bar pressure will occupy 206 meter cube. Whereas if you go on increasing the pressure, you see it reduce. When you increase the pressure to 1 kilopascal, it becomes 129. You increase to 10 kilopascals, it becomes 14 meter cube per kg. And for 100, it becomes 1.69 meter cube per kg. So as the pressure increases, the specific volume reduces, you can see. And now there you can see a VF and VG. So VF is for the saturated liquid and VG is for the specific volume for the saturated vapor. Now the values in between this, whatever is there, that is the mixed region. If you suppose when you are solving a numerical, you are getting a value which is in between this, then the you can say that the wet steam, it is a wet steam, it is not saturated liquid also. Saturated liquid means 0.001 meter cube per kg. If at let us say zero point 0.6 bar 0.6 kilopascal we are seeing first row. So if the value is 0.001, we can say it is saturated liquid. If the value is 206 meter cube per kg, I can say it is saturated vapor. But if suppose the value is 100 meter cube per kg at a pressure of 0.6 kilopascal, then I will say it is a wet steam. Anything between these two is a wet steam. Now coming to specific enthalpy. Specific enthalpy for this, we will consider, now let us take 100, that is 1 bar atmospheric pressure. This last line whatever is there is for 100 kilopascal, that is almost 1 bar. Here the saturation temperature is 99.62 or 100 degrees centigrade. The specific volume is 0.001043 meter cube per kg for saturated liquid and 1.694 meter cube per kg for saturated vapor or dry saturated vapor. And similarly the specific enthalpy, again specific means average for per kg. So specific enthalpy of water at this atmospheric pressure is 417 kilojoules per kg of the fluid, and the specific enthalpy of the dry saturated vapor is 2675 kilojoules per kg. So if the value, suppose you get for a normal atmospheric pressure or 100 kilopascal pressure, if the specific enthalpy you are getting it as 1200 kilojoules per kg. So it is not saturated liquid and it is also not saturated vapor. So it is in between and we will call it as a mixed region. Okay, if it is the specific enthalpy you get as 2675.5 kilojoules per kg, then we can say it is a dry saturated steam. And if you get beyond, suppose you get 2900 or 3000 kilojoules per kg, then you can say it is a superheated steam. It is not dry saturated, it is the enthalpy is beyond Hg, then it is called as it is in the superheated region. Similarly, the entropies you can see for 100 kilopascal, entropy of liquid, saturated liquid is 1.3025 kilojoules per kg Kelvin, and entropy for saturated vapor or dry saturated vapor at 100 kilopascal is 7.3593 kilojoules per kg Kelvin. So if the value is 1.3, we will call it as saturated liquid. If the value is 7.35, we can call it saturated vapor, and if the value is beyond 7.35, we will call it as superheated vapor, and if the value is less than 1.3, then we will call it as compressed liquid. Please understand, anything value lesser than this SF or HF or VF, we will call it as compressed liquid, and anything value greater than Vg, Hg and Sg, then we can call it as superheated vapor, and value in between Vf, Vg or HF, Hg or SF, Hg, we will call that as a wet liquid or a wet steam. Okay. Now you can see for further we have seen for up to 100 kilopascal, that is 1 bar. Now you can see this table we have gone up to 1000 kilopascal here. Now you can see, as I was telling, 10 bar, I give example, 10 bar or that 1000 kilopascal, the boiling point is 180 degrees centigrade. You can see the last row here, last row, 1000 kilopascal is nothing but 10 bar. Here it is, please remember 100 kilopascal is equal to 1 bar. So 1000 kilopascal is equal to 10 bar. So here the boiling point or saturation temperature is 180 degrees centigrade, 179.91. So you can round it up to 180 degrees centigrade. So water at 10 bar, when the pressure increases, like in pressure cooker, when the pressure increases, the boiling point also increases. So this is what about steam tables. In steam table, you will come, for any given pressure, you will come to know the saturation temperature, one thing, because they are both interdependent properties in the wet region. We are talking only on the wet region. Then you have got the properties of specific volume, specific enthalpy and specific entropy, both for saturated liquid as well as saturated vapor. And any value which is less than the saturated liquid level value, that we can call it as a compressed liquid. If the value is in between the saturated liquid and the saturated vapor, then we will call it as a wet steam. And if the value is beyond the value of the uh, saturated vapor or dry saturated vapor, we will call that as a superheated steam. I think these things you please once or twice you watch this, listen to that, and then you will understand and appreciate, and so that you can solve the problems very easily. Thank you.